Hello everyone and welcome back to the channel. This video is another lesson from my upcoming Solutions Architect course. This time taking a look at EC2 storage options. We take an in-depth look comparing EBS storage to Instance Store, explore some of the differences, use cases, and some of the cost dynamics there as well. So let's dive in. Hi everyone and welcome back. In this lesson, we're diving into a really fundamental aspect of working with Amazon EC2 instances, and that's storage. Now, we learned about EC2 instances and different instance types, but where does the operating system actually live on these virtual machines? Where do we put our applications and our critical data, or even just temporary files? That's what EC2 storage options are all about, and understanding them is really key to building effective and resilient solutions on AWS. So first off, why do EC2 instances actually need storage in the first place? Now, it might seem obvious, but just like your own laptop or desktop computer needs a hard drive or SSD, an EC2 instance, being a virtual server, absolutely needs storage for several critical functions. Every instance needs a place for its operating system, whether that's Windows, Amazon Linux, Ubuntu, and so forth, essentially to boot up and run. This initial boot disk is often called the root volume, and it contains all the essential OS files. You can think of this as the C drive on Windows or the root file system on Linux. Now, beyond the OS, you likely want to install your own software, maybe a web server like Apache or Nginx, a database engine, or your company's custom applications. All of these need disk space to be installed and to function. And of course, there's the data itself, whether it's website files, user information in a database, application logs for troubleshooting, or even temporary files created during complex calculations. Your applications generate and consume data that needs a place to live. So storage is clearly important for our EC2 instances. So how does AWS provide it for EC2? When you launch an EC2 instance, AWS primarily offers two distinct ways to provide the necessary block-level storage. Think of block storage like a raw hard drive that the operating system can format and manage. The two main players here are your Elastic Block Store, or EBS, and as the name hints at, this offers flexible network-attached disk storage. Then on the other hand, we have storage that's physically located on the same hardware that's hosting our EC2 instance, and this is often called ephemeral storage, and that word is key. The fundamental difference here really boils down to persistence, whether your data sticks around or disappears. So let's go ahead and break down these EBS volumes first. First up is the workhorse of EC2 storage, our Elastic Block Store, or EBS, network-attached storage. Imagine it less like an internal hard drive and more like plugging in a high-performance external drive into your computer using a very fast network connection within AWS's infrastructure. This attachment over network means it can be a tiny bit more latency compared to physically attached storage, but it provides incredible flexibility, which we'll get to shortly. Now, this is arguably the most crucial feature of EBS. It provides persistent block storage. And again, what does persistence mean here? It means EBS volumes exist independently of your EC2 instance's lifecycle. So if you ever need to stop your EC2 instance, maybe for maintenance or cost savings if you're shutting it down after hours, or even if you terminate it completely, the data on any attached EBS volume remains safe and sound. You can then detach that EBS volume and reattach it to a different instance if you want, maybe a newer or bigger EC2 instance, just like moving an external USB drive between computers. And this persistence is vital for a lot of applications. So again, a good way to think about EBS is like having a high-performance, reliable virtual external hard drive that lives securely in the AWS cloud and ready to be connected to your instances. Now, we'll touch on some of the core features of EBS to be aware of. Just to hammer this point home, data on EBS survives instance stops and terminations, and this makes it the go-to choice for any data that you can't afford to lose, like your operating system, databases, or user files. Then building on persistence, EBS allows us to take point-in-time snapshots of our volumes. Think of these like highly reliable backups. These snapshots are stored durably and cost-effectively behind the scenes in Amazon S3, and what's really great is that these snapshots are incremental, meaning that after your first full snapshot is taken, AWS only saves the blocks that have actually changed since that last snapshot. This saves us a ton of storage space and cost, and makes future snapshots of that volume even faster. You can use these snapshots to easily create new EBS volumes, which are great for cloning servers or entire environments, or to restore a volume to a previous state, which becomes a very useful capability for disaster recovery. EBS is also incredibly flexible. You aren't stuck just with one type of disk. You can choose from different volume types, optimized for various needs. You can pick from the high-performance solid-state drives or provisioned IOPS volumes when you need maximum speed for things like databases. There are also lower-cost hard disk drives when you need high throughput for things like log processing or data warehousing at a lower price. Another feature is that you can often resize these EBS volumes. If our storage needs change over time, we could increase their size for more storage capacity or even change their type for different performance characteristics. With supported volume types, we can make changes dynamically without detaching them from the instance, allowing us to scale our storage easily as our needs grow with minimal interruption to our EC2 instances. Now, similar to EC2 instance types, EBS offers a variety of volume types for different needs, and we'll explore these shortly as a separate lesson. And finally, securing our data is critical. EBS offers straightforward options for encryption. You can easily enable encryption for data at rest on the volume itself, as well as data in transit between your EC2 instance and the EBS volume. This helps you protect your sensitive data and meet any sort of compliance requirements with minimal effort. So given these features, particularly around persistence and flexibility, when would you typically reach for EBS as an option? So almost universally, the root volume where your OS lives for an EC2 instance would be on an EBS volume. You of course need your operating system to persist if you stop and start the instance. Also, any kind of database that needs its data to be durable, if we think relational databases here like Postgres, MySQL, SQL Server, or even NoSQL databases like MongoDB, these should run on EBS storage. And next, really any kind of standard business application, workload, or file server that requires reliable persistence block storage is really a prime candidate for EBS. Really, anytime you need a traditional file system to store data that needs to survive instance stops or even complete replacements, EBS is certainly the way to go here. Now let's switch gears and quickly talk about Instance Store, and the key word to remember here is temporary. This direct attachment is key to the benefits that Instance Store volumes provide. Unlike EBS, which uses the network, Instance Store volumes are storage devices, often really fast SSDs, that are physically located on the same physical host server that our EC2 instance happens to be running on, and this direct attachment is key to its main benefit, which is speed. But there is a critical trade-off here, and it's a big one. Instance Store provides temporary or ephemeral block-level storage. Now, what does ephemeral mean in this context again? It means that data stored on an Instance Store volume is directly tied to the life cycle of that specific running instance. If anything happens to that instance, the data is likely gone for good. Now we'll go over exactly what scenarios can cause this type of data loss in just a moment. So again, I want you to think of Instance Store not like a permanent hard drive, but more like an extremely fast temporary storage, almost like a RAM disk or a super fast internal scratch disk that gets wiped or cleaned regularly. It's built for speed and not necessarily for keeping data safe long term. Now, because this storage is physically attached right there on the host machine, essentially bypassing the network hop needed for EBS, Instance Store often offers significantly higher random I/O performance, or IOPS, and much lower latencies. For applications that need the absolute fastest possible access to temporary data, this can be a major advantage here. Now, let's be crystal clear about the temporary part. This is the single most important thing to understand about Instance Store. Your data here is not persistent in several common scenarios. If you stop your EC2 instance using the stop action in the console or API, which essentially deallocates the underlying host, all the data on the Instance Store volume is permanently lost. Now, this action is different from a simple operating system reboot. A reboot typically keeps the Instance Store data intact because the instance stays on that same host hardware. However, a stop and start cycle means guaranteed data loss for that Instance Store volume. Now, this one might be a little bit more obvious, that if you terminate the instance entirely, the Instance Store is destroyed along with it, and again, your data is gone forever. Now, since the storage is on the physical hypervisor host, if that specific piece of underlying AWS hardware experiences some type of failure, the data on the instance store attached to the instances running on that host can also be lost. Now, EBS being network attached and having built-in redundancy within its availability zone, it's designed to protect against single hardware failures. It's also really important to know that instance store storage volumes aren't something you can just attach to any EC2 instance like EBS can. It comes bundled with a specific EC2 instance type, and often those are optimized for storage I/O like the I series or D series or high-performance computing. Now, if we circle back to our EC2 instance types, we can see that most of the EC2 instance families are EBS only. The exceptions again here being the storage optimized category, where we have our I, D, and H families. If we go to our general purpose category with the latest M8G type, we can see these instance options here are all EBS only instances. Now, if we step back a generation of these Graviton-based instances to the M7G, we see here we get a variation that have NVMe drives available for instance store volumes. Now, if you recall, we talked about the extra feature letter of the EC2 instances naming conventions in the earlier lesson, but again, as a recap, we can see here that we have the M7GD named instance, D for disk, and these are the only ones that have this extra feature of instance store capabilities as well. Now, keep in mind the amount and type of instance storage is fixed based on the instance type you choose. You don't have the flexibility to dynamically change the size and type of storage here like you do with EBS. So given the great speed capabilities, but its highly temporary nature, where does instance store-backed volume storage actually make sense? Well, it's perfect for things like web server caches, database query result caches, or a session state storage where speed is critical for performance, but the original source data should exist elsewhere, like in a database, perhaps again on EBS or in Amazon S3. If the instance store data is lost, the cache can simply be rebuilt from the source without any permanent data loss. It's also really useful for applications that need buffering of incoming data quickly before processing it and potentially storing the results somewhere else. Now, this is an important use case here as well. Instance Store is really ideal for applications that need a temporary scratch workspace for things like video encoding, image processing, or large-scale data transformations, where its intermediate files are generated and then they're essentially discarded once the final result is computed and the final result data is maybe saved to persistent storage like EBS or S3. Also, certain types of distributed file systems like Hadoop HDFS or some distributed databases can leverage Instance Store for performance, but they need to have their own kind of built-in replication mechanisms. These would essentially achieve data durability by automatically copying data across multiple nodes in a cluster. So if any one node's instance store fails, the data still exists and can be rebuilt from the others. Relying on instance store storage without this type of built-in application-level redundancy for your critical data is very risky, and you're bound to lose data. Now, we've covered a lot about both types of EC2 storage options at this point, so let's quickly summarize the crucial differences we've been discussing, looking at them side by side in this comparison table. First up is persistence, and this is a big one. EBS is, again, persistent, and the data survives the stops and terminations and hardware failures within its AZ. Instance store data is temporary, and your data is lost on stop, termination, or any kind of underlying hardware failure. Looking at our EC2 instance attachment features, EBS is again network attached, offering a lot of flexibility, but it introduces some network latency. Instance Store is physically attached, being local to the physical hypervisor host, and therefore offers very low storage latency for our EC2 instance. On the performance side of things, Instance Store generally offers the highest raw, IOPS, and lowest latency, especially with the NVMe types. And then on the other hand, EBS performance is very good and highly configurable with different volume types, allowing us to pay for the performance we need, but it usually has a slightly higher latency than Instance Store, again, due to the network aspect. Now, as for data loss risk, for EBS, the risk is really low thanks again to its persistence and snapshot backup capability. For Instance Store, the risk of data loss for a single volume is quite high, and the durability requires designing our application for replication and or taking frequent backups if the data is really important. Otherwise, you just need to accept that data loss will eventually happen with your EC2 instance during any type of lifecycle change or hardware failure. Now, for use cases, we saw that EBS is ideal for your OS, databases, and any kind of persistent application data. Then jumping to EC2 lifecycle independence, our EBS volumes have a life that's essentially independent of a single EC2 instance. Instance store volumes, on the other hand, are tied to the life and health of one specific running instance. And then lastly, for billing, remember EBS is billed based on the provision size, per gigabyte per month, and potentially on different performance characteristics like IOPS and throughput, while the instance store cost is essentially included in the hourly price of the EC2 instance type that provides it. Now, all the information we've been looking at essentially brings us to the crucial choice of how do we decide which one to use here? It usually comes down to answering a few key questions about our workload. Do I need the data to persist if the instance stops or terminates? This is almost always the first and most important question to ask. If the answer is yes, that you absolutely need the data to survive, then EBS is almost certainly your choice here. You don't want to try to work around using Instance Store here unless you really have a very specialized use case with robust replication. Now, if your answer is no, and that your data is truly temporary or easily recreated, then Instance Store might be an option here, leading to the next question. What are my performance requirements? Do you need the absolute lowest latency and highest possible IOPS for your temporary data? If it's yes and your chosen instance type offers it, then Instance Store could be a great fit. Or do you need reliable, predictable performance for your persistent data, maybe even guaranteeing a certain level of IOPS? Then you want to choose the appropriate EBS volume type that meets your specific needs. Another question to ask would be, can my application handle data loss on a single node? This again ties back to persistence. If the answer is no, that losing data on one instance would be catastrophic, then certainly use EBS here. If the answer is yes, perhaps because the data is replicated across multiple instances anyway, or because it's just a cache that can be repopulated, then Instance Store remains a possibility here. Now, while often secondary to persistence considerations, cost can actually play a role in the decision as well. High-performance EBS volumes can be more expensive than general-purpose ones. Instance Store storage comes arguably free with certain instance types, which could be very cost-effective if you needed that instance type anyway, and you can leverage that temporary storage. You just want to be sure that you don't choose Instance Store just to save some costs when you actually truly need persistence. All right, let's quickly recap the main takeaways here from this lesson. Again, EBS is your persistent network-attached storage. We want to think of EBS as your reliable, durable storage solution, like a virtual external hard drive in the cloud. It's network-attached, its data persists independently of the instance, and it's the standard choice for operating systems, databases, and any critical data that we need to keep safe. Also remember to leverage the snapshot features for your EBS volume backups. Then our Instance Store storage is temporary and locally attached. We can think of Instance Store storage as our blazing fast but temporary scratch space. It's physically attached to the host for maximum speed, but the data will be lost if the instance stops or terminates or that underlying hardware fails. It's best suited for caches, buffers, and processing temporary data where loss is acceptable or managed some other way by replication. Ultimately, your EC2 storage decision boils down to your application's requirements. Does the data have to survive independently of the EC2 instance? If yes, choose EBS. If not, you want to consider the performance benefits of Instance Store, and if that outweighs the temporary nature for your specific use case. Understanding this fundamental difference between EBS and Instance Store is really critical for designing and building resilient, performant, and cost-effective applications on AWS, so make sure you choose wisely based on what your application truly needs. Now, that covers the core concepts of EC2 storage and comparing EBS and Instance Store. You should now understand the key differences, the trade-offs, and when to use each one. So thanks for joining me in this lesson, and see you in the next one.